Hi, this is Pam Price or CSProfessor Pam with PamTech Coding. I create videos that take complex programming concepts and break them down into bite-sized pieces. So, previously we talked about while loops, and I want to talk about another concept that is closely connected to loops, which is the idea of a variable that acts as a counter or an accumulator. So we've actually already used a counter. When we used our loop before, we had a variable that we added 1 to every time. That basically means it is counting something. If you think about those little clickers that people used to use to count the people as they enter an event. So if I have a variable called count, it's important to initialize it to 0. And each time I want to increment it, I need to add 1 to it. So again, it's important to understand if we look carefully at this statement. When you look at a statement with an equal sign in it, you have to remember this is an assignment statement. That is what this operator is. It is the assignment operator. Most things in programming you do not read from left to right as if you're reading words. You have to interpret this differently. So when you see an assignment statement evaluates what is on the right side, and whatever value you come up with gets put in the variable on the left side. So if count is initialized to 0, when I first encounter this statement, then here on the right side, count is 0. 0 plus 1 is 1. We place that into count. That means the 0 that was there goes away and the new value is 1. So that is incrementing, and we can do it with count equals count plus 1. Or remember, these are two alternate ways to do that. This is our plus equal operator, which you can use with all the different operands. Again, it's just another way of writing this. Or if you're only adding 1, you can say count plus plus. It only works for adding 1. And just to remind you, there is also a minus minus operator if you want to subtract 1. All right, now, an accumulator is a really important concept to understand. An accumulator is a variable that sort of acts as a hoarder. I'm using the word hoarder. You know, people who like to keep what they have and get some more. That's the concept that I think of with an accumulator. And here's the way I'm going to explain it. Suppose I'm going to give you a series of numbers, and your job in the game is to be able to tell me what the sum is without adding them all up and having to do it at the end. Like, you want to be able to give me the answer as quick as possible. So I'm going to give you a series of numbers. And remember, your job is to keep track of the sum. So if I tell you the first number is 2, you are keeping track in your head that the sum is 2. If I tell you the next number is 5, you don't care about the 2 anymore. The sum is now 7, right? If I tell you the next number is 3, you don't care about the 7 anymore. The sum is now 10, right? Let's say that that's all we're doing. So let's think about how we get to this point. So remember, actually our variable sum is initialized to 0. When I get the first number, this 2 is my previous value sum plus my new value num is what gives me 2, right? The previous value plus the new value. When I get the 5, this 7 is my previous value 2 plus my new value 5 gives me the 7. This 10 is my previous value 7 plus my new number 3 gives me 10, right? So each time my new value of sum is equal to my previous value of sum plus the next number. So this is a statement, whenever you see something like this where you're using the same variable on both sides, chances are it is acting as an accumulator. If I see x equals x plus y, my thought is that x is acting as an accumulator. So let's say that what I want you to do is add up all the numbers from 1 to 5. All right, you have to think about how to break this problem down and solve this problem. And the way I think of it is, I cannot even worry about adding the numbers up unless I can first just generate what the numbers are from 1 to 5. So to me, this starts with just a counting problem. So remember we did this before. So I'm going to say let num equal 1. I'm going to have a loop that says while num is less than or equal to 5. Inside I'm going to print num, and then we need to update. So I'm going to say num plus plus, right? And the first thing I want to do is see, did I print out 1, 2, 3, 4, 5? Okay, so let's take a look over here, right? Let me double check that I'm actually running this current code. All right, let's just start it up again and inspect. All right, so there are my numbers, 1, 2, 3, 4, 5. All right, but I don't want to, so here we were printing the number, right? Instead of printing the number, that's not what I want to do. I need, so first of all, I need another variable. If I want to add up the numbers, oh, I have it right there, from 1 to 5, then I'm going to need, I need an accumulator for the answer. So I'm going to call it sum. You should call it a name that makes it sound like it's the total. I would call it sum, or maybe total, or maybe answer. All right, so I have this accumulator. So now when I get this number, instead of printing it, I want to add num to my accumulator, which is sum. That means I want to take the current value of sum, add num to it, and that becomes my new sum, right? Right? And then when is the answer done? The answer is not done until I complete the entire loop. As a matter of fact, before we do that, so let's take a look. Remember I tell you we should always take a look at things. So I'm going to console log sum. All right, let's take a look. Now let's understand what we're getting here in this console log. Let me just hide everything over here. All right, so sum is 0, num is 1. 1 is less than or equal to 5. So sum is 0 plus 1 is 1, and that's what we're printing out as sum. All right, now we come back through, num is 2. Sum was 1 plus 2 means sum is now 3, right? Num becomes 3. Sum was 3 plus 3. Now sum becomes 6. Num is 4. We have sum, which was 6, plus 4. Sum now becomes 10. Num becomes 5. My previous sum, 10, plus 5 becomes 15. So if all I want is the answer at the end, I don't want this. I want to, now at the end of the loop, I print the answer. The sum is, okay, and we get 15. Let's test it with another number. Let's say we only do 3. So this should be 1 plus 2 plus 3, which should be 6, right? The sum is 6. So this is a very common algorithm, a very standard algorithm to add up. Each time in this loop, I'm getting a new value every single time. If we wanted to turn this into a function, all right, let's make a function called calcsum. And it gets a parameter, which is going, and so its job is going to be add up and return the sum of the numbers from 1 to num. Okay, I'm going to actually take this code and we'll modify it. I'm going to actually move it inside of this function. We're going to modify it a little bit. Oops, my indenting did not work, but I can grab it and move it over. All right, so it's no longer 1 to 5. It's from 1 to num. We still need an accumulator. I need to call this something else, because if I'm going to call, let's call this parameter, I'll call it max instead of num. So we want the numbers from 1 to max. You have to be careful about your variable names like this. So sum is 0, num is 1. Or actually, let's do this. Let's call this variable count, because it is acting as a counter. So that's actually a much better name for this, because we're counting the numbers. So I'm going to leave this as num. All right, sum is 0, count is 1. While count is less than or equal to num, because num is our ending number, what we want to do is add count, we don't need this, to my accumulator. So sum equals sum plus count, and then we update count. We're not going to, we could print the answer just to see if it's working, but I really want to return the answer. So this function is going to return sum. And actually, I don't want to print it there, because I want us to understand what we have to do when we call a function that has a return value, right? So here's my function. So let's call it calcsum 5. Remember, we know the answer is supposed to be 15. And I don't get anything. Where is the answer? Now, let's just uncomment this so we can see if anything is happening. And yes, it did go into the function and it is doing it. But if this function is going to return the answer, then I need to console log this, because this call to this function is going to come back with an answer. And that, in order to see it, I need to console log that answer, right? If I change this to 10, what's the sum of the numbers from 1 to 10? It's 55, right? So I have to console log it, or just alternately, the other thing I could do is I could say let total equal calcsum, right? And then I could print total here. All right, so now we can see what we did. But remember, when I broke down how to do this problem, I said, first of all, I needed to figure out how to generate the numbers from 1 to whatever. And then I needed to accumulate them. I also want to show you one more thing. The order of statements is very important. Okay, I'm going to take this back. Let's just do 3. We're going to do an easy case. So suppose I put this statement in the wrong place. I want to undo. All right, I'm going to comment it out. You know, you say, well, does it matter where I put it? let's put it here. Now I'm calling calcsum 3. So this is supposed to be 1 plus 2 plus 3, right? So it should be 6. I'm getting 9. Now, this is really important. When you don't get the right answer, you have to figure out why you didn't get the right answer, okay? Let me do, and you literally need to walk through your code and understand what it is doing. So let us do that here. So over here, my variables are, I have num, which remember we passed 3. I have sum, which is 0. I have count, which is 1. All right, I'm on this loop. Is 1 less than or equal to 3? Yes. What am I doing? Count plus plus tells me to increment this. And now I'm saying sum equals sum plus count. You can see the problem already. We lost the 1, right? But let's just walk through it and make sure we know why we're getting the answer that we're getting. So now, is 2 less than or equal to 3? Yes. This is going to become 3. 3 plus 2 is 5. Okay? So we have 3. We're back to the loop. Is 3 less than or equal to 3? Yes. This gets incremented to 4. 5 plus 4 is 9. Count gets incremented to, no, we just incremented, so we have 9. So 4 less than or equal to 3 is false, and the loop ends, but 9 is the answer that we are going to return, right? And we have the right statements, but they are in the wrong order. So problem solving and being able to read your code and walk through and figure out why it is not working is very, very important. You can't just stare at your code and try to figure out what's going on. You need to play computer and walk through it and understand what is going on in the variables. All right? So hopefully that helps you understand better. Again, count here is acting as a counter. I'm adding 1 every single time. Sum is acting as an accumulator. It's a hoarder. It's keeping what it already has and adding something else to it, and that becomes the new value. Hopefully, counters and accumulators are clearer to you now. If you have any questions, please leave some comments and just keep practicing. That's the only way you get good at this, is to keep practicing. So for example, if you want a little problem to think about doing, why don't you change this and make a function called calcEvens? And its job is going to be to add up and return the sum of the even numbers from 2 to whatever you give it, right? So if I say calcEvens and pass it 4, I want to add up 2 plus 4. Now, if I say calcEvens and pass it 5, I still want to add 2 plus 4 because those are the only even numbers less than 5. But if I say calcEvens and I pass it 6, I want you to add up 2 plus 4 plus 6. All right, so that's your challenge. Have fun coding, and we'll see you in the next video.